All right, now let's do some proofs. All right, so the first one says PQ is congruent to SR. So QN is congruent to RN. Okay, we want to show that PN is congruent to SN. All right, so is this one addition or is this one subtraction? This one is addition. So I'm going to say PN. Again, I just wrote givens. We're just shortening it like that. So PN is congruent to SN. Okay, so here we're adding two sets of congruent segments. So if congruent segs are added to congruent segs, then the sums are congruent. Okay, next one. All right, AE is perpendicular to CX, so these are right angles. AXB is congruent to EXD, which is that one. And we want to show that it bisects this middle angle BXD. So kind of we're trying to show that this angle is congruent to that angle. Okay, so we've done this kind of same thing before with complements. So you could do like right angles and then say they're complementary. But I'm going to show you how we could do it with addition and subtraction this time. Both would be okay on like a test or something. Okay, so first I have to get that there's right angles. So I'm going to say angle AXC is right. And that angle CXE is right because perpendicular segments form right angles. So if segs are perpendicular, then they form right angles in the same reason. Okay, so that's how I had the right angles. So in the past, we would now say the angles are complementary, but we're not going to do it that way. So this way, we're going to say that the right angles are congruent. So I'm going to say angle CXE is congruent to angle AXC because if angles are right, then they are congruent. Okay, so the reason we had to do that is in order to use subtraction, which we're going to do next, we need to get the bigger angles congruent, which are the right angles. You need to have one set of smaller pieces congruent, which are those, and now we can use subtraction. So you couldn't use subtraction until you get the big angles congruent. And saying the right isn't enough. Okay, so now we can say angle BXC is congruent to angle DXC. Okay, because we are subtracting congruent angles from congruent angles. So if congruent angles are subtracted from congruent angles, then the method of subtraction is differences. Differences are congruent. Okay, so we haven't said that they bisect it yet. And I ran out of room, so I'm going to kind of shift everything up a little. So now I can say angle, or ray bisects angle BXD because it divides it into two congruent angles. So if ray divides angle into two congruent angles, then it bisects the angle. Okay, so we proved that the thing we're trying to show with the last step.